Hey everyone, welcome back to the channel Code with AKJ. Today is day 32 of solving LeetCode 75 challenge series. So today's problem is maximum twin sum of linked list. So if you are new to the channel, please make sure to hit that subscribe button and turn on the notification so that you never miss an update. So let's get started. So the problem statement says in a linked list of size n where n is even, the ith node that is 0 indexed of the linked list is known as the twin of the n minus 1 minus ith node, that is if 0 is less than I less than or equals to n by 2 minus 1. So for example, if n is equals to 4, the node 0 is the twin of the node 3 and node 1 is the twin of node 2. So these are the only nodes with twins for n is equals to 4. So the twin sum is defined as the sum of a node and its twin. Given the head of a linked list with even length, return the maximum twin sum of the linked list. The problem statement says we are given a linked list of even length where a node at index I has a twin node at index n minus 1 minus I. The twin sum is the sum of a node and its twin, and our goal is to find the maximum twin sum in the linked list. So let's quickly understand this given problem statement with these examples. So I've written down these two examples, which is 5421 and 4225. So since these are zero based index, I've written here index values, that is 0123 0123. So let's start with this particular linked list. So the twins here are 0 and 3 and 1 and 2. So the sums of these twins are 5 plus 1, that is 6, 4 plus 2, that is 6. So the maximum of these two sums are max of 6 comma 6, that gives us 6. The answer for this given first linked list would be 6. So coming to the second example, we have values 4, 2, 2 and 3. So the twins here are the nodes with index 0 and 3 and 1 and 2. So 0 and 3 values are 4 plus 3, that gives us 7, and the index 1 and 2 gives us 2 plus 2, that is 4. So the maximum twin sum of these two values are max of 7 comma 4, that gives us 7. So for this given linked list, the maximum twin sum would be 7. So this is what the problem statement says. So now let's look at the brute force approach first. So let's start with our brute force approach. So the idea here is to store all the values of our linked list in an array, and we'll iterate from 0 to n by 2 and we'll compute the twin sum. And finally we'll return the maximum twin sum. So this would be our brute force approach. So let's quickly understand our brute force approach by dry running with this given linked list example. So our first step here would be to store all these linked list values into a vector with the help of a temp pointer, which would be pointing to head initially. We'll move this temp pointer until or unless it reaches the null. We'll store all these linked list node values into a vector. So our vector would be something like this, that is 5, 4, 2 and 1. Second step here would be to iterate over this vector till n by 2, that is till 0 and 1 in this case, and we'll calculate the twin sum. So here twins would be for every index I, n minus I minus 1. So we'll use a for loop, and for every index we'll find its twin and we'll calculate the twin sum, and we'll also use a max sum variable which would track the maximum twin sum. And finally we'll return this max sum, which would give us the maximum twin sum for this given linked list. So this would be our brute force approach. So let's quickly dry run this. So since we have stored all these values into our vector, so the size of our vector would be 4. So n by 2 gives us 2. So we'll run a loop till n by 2. So for index 0, the twin would be 3. So the twin sum becomes 5 plus 1, 6. So max sum initially would be 0. So max sum updates from 0 to 6. And we'll move to the next index. So for index 1, the twin would be index 2. So we'll calculate the twin sum, that is 4 plus 2, 6. So we'll update with our maximum. So maximum of 6 comma 6 would be 6 itself. So the maximum sum would be 6. So when we'll move to the next pointer. So since the index moves out of the bound, that is n by 2, we'll stop our iteration and we'll return our maximum. So our maximum variable contains value 6. So for this given linked list, our answer would be 6. So let's take one more example. 4, 2, 2, 1. So again, we'll try to store these values into a vector. So our vector contains 4, 2, 2 and 1. So we'll iterate till n by 2, that is index 0, 1, 2 and 3. So for every index we'll try to find its twin and we will try to calculate the twin sum. So for index 0, the twin would be 3. So the twin sum would be 4 plus 1, which gives us 5. So maximum sum would be initially 0, should be updated to 5 now, and we'll move to the next index. So for index 1, the twin sum would be 2. So we'll calculate the twin sum, that is 2 plus 2, which gives us 4. So we'll try to update our maximum. Since 5 is greater than 4, the maximum sum remains 5 itself. So it goes out of bound for the next iteration, and we'll try to stop our iteration here, and we'll try to return our maximum variable which stores the value 5. So for this given linked list, the maximum twin sum would be 5. So in this way our brute force approach works, and the time complexity of our approach here would be O of n, since we are traversing over our linked list, and O of n as we are trying to iterate over a vector as well. And the space complexity here would be O of n as well, as we are using vector to store all the linked list values. So let's quickly code this approach and let's submit. So here's the code for our brute force approach. So we'll take a vector of values which would store all the linked list values. So we'll also take a temp pointer which would be pointing to head. So initially we'll store all the linked list values in an array with the help of a temp pointer. So till it reaches null, we'll try to push all those temp values into a values vector, and we'll move our temp pointer to the next node. And finally, after storing all those linked list values into an array, we'll also take a maximum variable which would track the maximum twin sum. We'll calculate the values vector size, and based on its size, we'll try to compute twin sums by iterating over our vector till n by 2. And for every index, we'll try to calculate its twin sum by adding values of I with values of n minus 1 minus I. And after calculating this particular sum, we'll try to update our maximum with this current twin sum. So after finishing our for loop, our maximum would contain the maximum twin sum of this given linked list. So finally, we'll return our maximum. So let's quickly run this code. So it's working, so let's submit. As you can see, this gives a successful submission, but as we know, the time complexity and space complexity here is O of n. So this solution works, but can we optimize it? Let's see. So let's get started with our optimal approach. So the idea of our optimal approach here is to find the middle of our linked list using slow and fast pointer approach. And our second step here would be to reverse the second half of our linked list. And final step here would be to compute our twin sum. So instead of trying to store all those values into a vector and try to find the maximum twin sum out of it, we are trying to do it in place by finding the middle of our linked list, and we'll try to reverse the second of our linked list to find the twins efficiently, and we'll finally compute the twin sum. So let's quickly understand with this given example. So first step, that is find the middle of our linked list. So this would be our middle of this particular linked list. So we'll try to reverse the second half of our linked list, that is our second step. So after reversing it, our linked list would look something like this, that is 5, 4, 1 and 2. And finally, with the help of two pointers, that is one pointer would be pointing to this particular node and one pointer would pointing to this particular node, that is the second half of our linked list. So we'll try to move these two pointers and we'll try to calculate the twin sum. So the first twin sum here would be 5 plus 1, which gives us 6. So we'll move these two pointers one step ahead, and we'll again calculate the twin sum, that is 4 plus 2, which gives us 6. So while computing these twin sums, we'll also track the maximum twin sum by using a maxsum, which would be initially 0. So in this way, our optimal approach works. So instead of using any extra space to store all these list nodes, we are trying to compute this twin sum in place by finding the middle node and trying to reverse the second half of our linked list to find the twins of every node efficiently. So the time complexity of this approach would be O of n, and space complexity of this approach would be constant, as we are not using any extra space to store any values. So let's quickly code this approach and let's submit. So this is a code for our optimal approach. Our first step here would be to find the middle of our linked list. So we'll use slow and fast pointer approach. So while fast and fast next is not null, we'll move these two pointers two steps ahead and one step ahead respectively. We'll also take a max variable which will store the maximum twin sum. And our second step here would be to reverse the second part of our linked list. So reversing of a linked list can be done with the help of three pointers, that is next, current and previous. So initially previous would be null. So our first step would be to find the next node, that is slow's next, and we'll change the pointer with the help of this step, that is slows next pointing to previous. And our final step here would be to move these two pointers, that is previous and slow, one step ahead. And finally, our third step would be to find the maximum of these twin pairs. So until or unless previous is not equals to null, calculate the current twin sum, that is head value and previous value, and we'll update this current twin sum with the help of max function. And after updating our max val variable, we'll move these two pointers previous and head one step ahead. And finally, we'll return our max val, which will store the maximum twin sum. So let's quickly run this code. It's working, so let's submit. As you can see, this gives a successful submission, and the time complexity of this approach is O of n, and space complexity here is O of 1. So before concluding, let's try to dry run this given optimal approach with an example to see how these pointers moves. So let's dry run our optimal approach with this given example. So our first step here would be to find the middle of our linked list. So we'll use slow and fast pointer approach. So initially both would be pointing to head. So until or unless the fast is not equals to null and fast next is not equals to null, we'll try to run a loop and we'll move the fast pointers two step ahead and slow pointer one step ahead. So since here fast is not null and fast next is also not null, so we'll move this fast pointer two step ahead. So it would be pointing to 2 and slow pointer would be pointing to 4. So again we'll check whether fast is not null and fast next is not null. So both conditions are true. So we'll move this fast to two steps ahead, that is it would be pointing to null right now, and slow pointer would be pointing to 2 right now. So now we'll again check the condition. So since fast is pointing to null, we'll stop our iteration. So this would be our first step. So here we found the middle of our linked list. So our second step here would be to reverse the second half. So reversing second half, that is in place, would require three pointers, that is previous, current and next node. So initially previous would be pointing to null, and current is here the small pointer, and next node will be calculating in our next step. So in reversing a linked list, our first step here would be to calculate the next node. So the next node would be the slowest next. So next node would be pointing to 1. And our second step here would be to reverse the pointer, that is slowest next would be pointing to previous. So here 2 would be pointing to null here, that is previous. And our third step would be to move these pointers one step ahead. So previous would be moving from null to slow, and slow would be moving from slow to next node, that is it would be pointing to 1. So in our second iteration, we'll again do these three steps. So our first step here would be to calculate the next. So next would be now pointing to null here. And our second step here would be to change the links. So once next would be pointing to previous. And the third step would be to move these pointers one step ahead. So previous would be pointing to 1 and slow would be pointing to null. So finally, after reversing the second half of our linked list, our linked list would be looking like this. So 5 is pointing to 4, 4 is pointing to null, 1 is pointing to 2, and 2 is pointing to null. And since previous is pointing to 1 and head is pointing to 5, our final step here would be to calculate the twin sum with the help of these two pointers, and we'll try to update these twin sums with the help of max variable, which would be initially 0. So we'll run a loop until or unless this previous pointer would be pointing to null. So we'll calculate the current twin sum, that is p values and head values. So 5 plus 1 gives us 6. So the current twin sum is 6. We'll update our max value with 0 to 6, that which gives us 6. We'll move these two pointers one step ahead. So now head is pointing to 4 and p is pointing to 2. Now we'll calculate the current twin sum, that is 4 plus 2, which gives us 6. And we'll update our max variable with this current twin sum. So max of 6 comma 6 is 6. So our max variable would contains the value 6. So right now p is pointing to null. So we'll stop our iteration and we'll return our max variable. So for this given example, our answer would be 6. So in this way, our optimal approach works. So let's move on to our space and time complexity analysis. So for our brute force approach, the time complexity was O of n and space complexity was O of n. Whereas in our optimal approach, where we have used a mixture of approaches, that is the slow fast pointer approach to find the middle of our linked list, a reverser of our linked list with the help of three pointers, that is previous, current and next, and finally with the help of two pointers, that is previous and head, we were able to calculate the twin sums. So the time complexity of this approach was O of n and space complexity was O of 1, which is constant space. So this optimized approach makes our solution efficient and scalable. So that's it for today's video. We have covered both brute force and optimal approaches for maximum twin sum of a linked list. So if you found this video helpful, smash that like button and subscribe for more coding videos. I'll see you in the next video. Thank you.